Oh, Anirban, can you? Okay. Okay, is it everything is clear, right? Audio is fine. You can see my screen. Should I start?
Yeah, miss.
Okay, cool. Okay, so lines and angles is a very small chapter, and only 2 or 3 important concepts are usually asked in as questions. But this chapter also has theorem, something called theorem, and something called axiom. We'll get to that. So, okay, there are still people joining. So we'll start with the basics. Okay. So we'll be using Zoom from now. Yep, I guess so. We might be using. Shivesh is requesting remote control of my screen. Shivesh, are you pressing something?
Yeah, man, there's a strange button, like I just pressed something by mistakenly and it's like hanged up.
Oh, you can try rejoining, do that maybe. Okay, I'm going to take a while today to figure this out because this is the first Zoom session I'm taking, so bear with me. I was talking of lines and angles, so okay, we'll start with uh, the very basic thing. Okay, so what is a line if I ask like a general question? Anybody?
It's infinite.
Okay, yeah, but in
Ma'am,
It
it
does not
does
have any
not have,
endpoints.
yeah, ma'am.
infinite points. Okay,
It extends infinitely in both directions.
yep, good. So yeah, so what you are saying is right. So basically a line is can be this, and can be infinitely long, right? That is a line.
And arrows.
Arrows. Okay, you want me to make arrows? Okay. So this is called a line or a line segment, and generally it is denoted by something like this, or with arrows, or sometimes it's denoted like this with points at the end, which means it's the line. Okay, just a second. Somebody is saying. Okay, I'm just talking of what is a line. I just started the chapter, so basically discussing what a line is, right? So line is like you all said correctly. It's a set of infinite points, you can say, or it has infinite length, right? Oh, I think. Oh, Anirban still cannot hear. Uh, I don't know what can we do now. Okay, I hope that gets resolved. So line can be represented like this, like this. Okay, so you are clear in what is a line, or it is also known as a line segment. Oh, okay. So the next thing, basically, okay, now I already find GoToWebinar better because I could see the chat, I could admit, people were admit in the meeting automatically admitted. Here I have to go and press and keep.
And you can
Make somebody co-host so that person will be in.
Yeah, somebody was saying something. Okay.
log the chat.
Okay, should I do that? I'll do that. Okay, leave it. I'll figure it out at some point of time. So basically, this is a line segment, and so two things I wanted to talk about. One is a line segment, right? So which is denoted by AB. It's a set of 2 points denoted like this. The other point is something a ray. Do you all know what a ray is?
Yes, ma'am, with only one endpoint.
Ma'am, one end is
Like it extends in one direction.
Okay.
One eye.
So you have a rough idea. Good. So ray is anything which is like there's a point at one end, okay, and it extends in one direction. Yeah, it can be infinite.
Your
Can
voice
be.
is lagging.
Sorry,
Miss, in between your voice is lagging.
my voice is lagging. Okay. Uh,
Now it's fine.
my connection. Okay. Hopefully it will be better now. Okay, so a ray is has a one point like this, and it extends in one direction. It can be infinite length. Okay, yeah. So a ray is generally denoted like this usually. So these symbols are actually not used, but there was a vague mention in the NCRT, so I just thought I'll share it. Normally, by convention, they just use AB. So AB can be length, array. It depends on the context. So by the context, you'll come to know what are they exactly talking about. Cool. So these are two things. So array has so basically in case of array, so this is array, and it has a point and arrow. So this point which is there is known as a this point which is there here is generally known as the vertex, right? So okay, these are the basic terms. Okay, now then a next concept which is there, so we've talked about, shall I just write it here? Maybe it will be better. Okay, so we have spoken about what is a line segment, then what is array. Now we'll talk about collinear points, or okay. So if 3 points, like suppose there are 3 points A, B and C. Okay. So now if I draw a line through them, like if I draw a line, you can see that all three of them are lying on the same line, right? So such points are known as collinear points. Yeah, if it is something like A is here, B is here, and suppose C is here. So they won't be collinear, right? Because you cannot have a straight line through them. One line going like this, maybe one line going like, okay. One line like this and another line like this. Okay. So basically, what are collinear points? They lie on the same line. Okay, so that's one more uh, definition which is important. Like they won't ask you things like define or anything, but as you solve problems in this chapter, you might just come across these words. So it's better that you know what they mean in advance rather than when you look at the question and you go blank or wonder that what are these terms. So we're done with collinear. Then next is something. Okay, so points are done. We'll move on to angle. So basically, this is a ray, right? This. Oh. This is a ray. Okay, suppose now I'm going to draw a ray in this direction also, using this as the same point. I'm drawing a ray like this. Okay, so this measure of this between the two rays, this I don't know how to define it without using the word angle. Okay, give me a second. Somebody, do we have to write this? You know what? Instead of sending chats, you can just ask me questions. I think that will be better. It'll be easier also. Yeah, you can write these things down. Okay, it's just basic concept, so you can write it. So now I'm trying to define what an angle is. Basically, an angle is made up of two rays with a common vertex. This is the measure, right? So, or it's also said that an angle is formed when two rays have a common vertex. Should I write that down? Do you want me to write that down? And angle is formed when two rays have a common vertex. Okay, you got it, right? So this, should I label it? So this is A, B, C. So AB is a ray, and also AC is also a ray, right? And they both have a common vertex, which is A. Okay, so this measure is nothing but this is called the angle. Cool. So simple definitions are done. So okay, they have also given the definition of a vertex. So these are basically AB and AC are basically known as the arms, right? These are the arms, and this is the vertex. If you want, you can note this down. These are just like basic concepts which you might have already done in your previous classes, like or previous lower standards. No, it's just basic. Okay, so you need to know what is a ray, then you need to know what are arms and what is a vertex. So this word vertex is used quite often. Okay, arms and all, they might not be used, but yeah, they might say having the vertex A, right? So for that, you need to know that. Okay, then this question I want you to answer. So since we are on angles, so there are different types of angles, right? So who's going to tell me what is an acute angle?
Less than 90 degrees. Less
Okay,
than
okay, less than 90 degree, but yeah, Netri, you can just answer. You don't need to raise your hand. No worries. Less than 90 degrees, yeah. You can just answer. Let it be interactive. Since there's not that much new concepts in this chapter, right? So when it comes to theorem, yeah, I'll explain. So acute angle is less than 90, but a better way of saying it would be angle between 0 and 90. So this is how you write if you want to denote. So x is an angle, it lies between 0 degree and 90 degree. Okay, so and then the next type will be right angle.
90 degrees.
Yeah,
90
Degree angle.
90 degree.
awesome. 90 degrees. So how do you write this? You just write it like this. So these x, y are just arbitrary, constants. You can choose A, B, C, anything. So by convention, usually angles are x, y, z or A, B, C, right? So this is how you write. Then what is another type?
Obtuse.
Yes.
Greater than 90, less
It's
than 180.
yeah.
90 to 360 degree.
90 to
No
360.
Sorry,
please.
90 to 180 degree.
Correct.
Yeah, between 90 and 180.
90 and 180. Okay. So okay. Then what else?
Reflex.
Okay, before we go to
It's more than 90 and
Straight.
Straight angle.
straight angle is
Straight is
180 degrees.
180.
180. Cool.
180 degree.
Yes. Right. And yes, last one is reflex.
Yes.
Reflex.
So
Greater
complete
than
angle.
More
180,
than
less than
180 and
360.
360.
Yes, so reflex lies between 180 and 360. Okay, so should I just, draw quickly in case anybody is confused? So if this is 30
Ma'am, there is also complete angle, right?
sorry,
Complete angle.
complete angle. Okay,
360 degrees.
Or
okay.
something like 0.
0 degree, I guess, will be a point, right? 360 will be a circle.
Yeah, 360 degrees.
Okay, cool. So you can add that also. Complete angle 360. So this is acute. You can write this down if you're like basic concepts, which just like a revision. You make a small note or just write this much like what I have written. Okay. Acute. So this is acute. Then this is right. And this is obtuse. Use. Then what?
Hello, ma'am.
Yes.
Hello, ma'am.
Yes, tell me.
You have done the, I guess you have done the obtuse angle wrong. Like, it should be greater than 90 and lesser than 180.
Huh. So, you were talking
Ma'am,
about.
Your signs, like,
Sign in 180 and Z is wrong. He's saying that.
No, no. So it will lie between 90 and 180. Getting.
Yeah, she's right.
Okay, so are you confused with these signs? So basically, okay, I'll explain it to you. So this means that x lies between 0 and 90. So when you write it like this, so automatically it means that x is greater than 0 and x is less than 90. So when you write these two in as forms of a statement, you write it like this. Okay, similarly for this case. So this case it will be z is greater than 90 and z is less than 180. Okay. So if I want to write it in just one statement, I'll write 90. So 90 will come first, right? Because z is greater than 90. So 90 comes first. So 90 is less than z and z is less than 180. Did you get it now? No response. Did whoever was asking, did you get it now? Yeah. So this is just a way of, if you're getting confused, just do, write it like this, like split it and write it that z is greater than 90 and z is less than 180. So this which I have written here is just a one step way of representing that those two statements. This basically means 90. So z is less than 9 is greater than 90, sorry, and z is less than 180. So out of z, 90 and 180, 90 is the least, so 90 comes first. Then 90 is less than z, right? And z is less than 180. Oh, my internet connection is unstable. Okay, so if you are facing difficulties in this sign convention, you can write it like I've written here at the side. Okay. Okay, so this is 180, right? Straight angle. Okay. And how do you denote a reflex angle? Okay, I did this exercise just to denote the reflex angle actually.
Miss,
This, yes.
Miss, I close in between.
Sorry, what? Aditya, could you repeat that?
You should, Miss, I think you should off your camera so your internet connection will be stable.
Oh, okay. Is it lagging or something now? Is there a problem?
But now it is not lagging. While time it was lagging.
Is it fine, all of you?
Yeah, Miss.
Yes, ma'am.
Okay, okay. Okay, so if there's any such issue, I'll switch off my camera. Okay. So this here is basically a reflex angle. Okay, you can write this down. Acha. Then next thing. Okay. Should I wait for you to copy it down, or you all have completed it? Should I go ahead?
Ma'am, it's done.
Done? Cool. Okay.
Ma'am, you're still lagging a bit.
Oh, should I switch off my camera? Will that be better?
Yes, please.
That will be better because your camera uses more internet.
Yeah, I agree. Okay, hopefully now it will be better. So now we spoke about different types of angles. Then there is a concept known as angle bisector. Anybody? What is an angle bisector?
Divides the line.
Ma'am, it's a line that divides
Divides an
the
angle equally.
It is the angle that divides an angle.
Into parts.
Okay, some say it's a line, some say it's an angle. Accurate definition will be it is a ray. Okay, so suppose this is an angle. Let me use 90° only as the example, right? So this is an angle ABC, which is 90°, and I draw a ray like this. This is BD, and BD is 45. So BD is a ray. In this case, it divides it equally. So it's not like always it should be equal. Okay, I'll take another example. So BD is basically a ray or the angle bisector. The ray which divides angle ABC into two equal parts. Right? So yeah, angle bisector will divide it into two equal parts, or there might be cases where there is another ray. So if this is a case that, 90° again, but this time the ray is somewhere here. So this will be just a ray. Okay, it won't be an angle bisector. Okay, should I just write it down? The definition, it is a ray which divides an angle into two equal parts. Okay. So now coming to the two most important terms which are going to be used throughout this chapter, and maximum number of questions come from these concepts. One is complementary angles. Okay, what is this complementary angle means?
Angles which sum
Sum of two angles is 90 degrees.
Which is sum of
Sum of
90 degree.
90 degrees.
Okay, so complementary angles are two angles whose sum is 90 degrees. Yeah, so write this down. This, like, most of the questions from this chapter are based on complementary supplementary angles, right? Next is supplementary. What is supplementary then?
They sum up to 180 degree.
Angles
180
which
that
are
means 180 degrees, basically a linear pair.
Awesome. So in this chapter, they ask you questions like an angle and its complement. You know, an angle is a complement of itself. Find the angle. Or they'll give you ratios, and they'll say two angles, 2x and 3x are complementary. Ria, you have a doubt?
No, ma'am, I accidentally pressed the wrong button.
Oh, it's okay, no worries. So yeah, they might give you ratios and they might ask you to find the angle. So basically, you know, these two concepts, if it's clear, you might get, you know, a bit confused between complementary and supplementary. So I don't know. Maybe you know, this may be a way that I used to remember, because it does get confusing after a point of time. Like, you know, you start wondering which is complementary, which is supplementary, because the words don't help you in real remembering that which is 180 and which is 90. So maybe this little trick, you know, maybe some of you can use it. So it's a C, right? So C को थोड़ा सीधा कर दो तो 90 हो जाता है, correct? So C complementary 90. Just a trick to remember which is 90 and which is 180. If you have any other ways of, you know, remembering or distinguishing them, then you can follow that also, or you can, you know, share it here so that your friends also know that they can use something like this.
Okay.
Miss, the C forms the curve of the 9.
C forms a
The C
curve.
comes first
C comes
and
first,
then
yeah.
S. Like,
That
so 90 comes first and then 180. So that
that's
you
an
remember that.
idea. That's a cool idea too. Yeah. So C comes first. So C is 90 and S is 180. Okay. Or, you know, like, I know this feels a little lame, but yeah, this is a sort of okay way of remembering which will be 90. Okay. So yeah, you can figure out something. Basically, the key point is not to get confused, because I'm sure that at some point we all definitely get confused that which is complementary and which is supplementary. Okay, so this is now we'll start with theorems and axioms. Okay, before that, one more concept I had to do. So there is something called adjacent angles. Anybody?
Angles who have a common arm.
Yes. Okay, quite close. Okay, so should I just draw something first?
MA divides the angle in two parts.
Sorry, I couldn't hear you. Can you repeat?
It divides angle into two angles. It's like a line which divides an angle into two angles, which some
Two
two
arms
right.
of an angle meet at a point.
Two arms of an angle meet at a point. No, that will be an angle only, right? So angle has two arms and they meet at a point. So this forms an angle itself. And the person who was saying it divides, I'm not sure if you should be using the term it divides an angle. Okay, I'll tell you how to. So basically, this is ABC and ABD. So this is angle ABD and this becomes angle ABC. So these two angles, so should I write it here? Angle ABD and angle ABC are adjacent angles. Okay. So how should I say, like, how will you give the definition? It is something like angles which have a common vertex, isn't it? This is a common vertex B, a common arm, AB is the common arm, right? And two non-common arms which are on different sides of the common arm. Am I making sense, or is it
Can you repeat?
Ma'am, can you repeat the
yes,
definition of
I'll write
adjacent
it down.
angles again?
Yes, I'll write
Yeah,
it.
thank you.
Basically, adjacent angles have a common vertex, which is B in this case, right? A common arm, which is
So
AB.
my maximum number can be only two, na?
Huh, 2. Because see, they need to have a common vertex and common arm, and the third point will be the crux. Why only 2? That the non-common arm should be on different sides of the uh, common arm. So if you extend it, the number of common arms keeps increasing, right? So they won't be adjacent anymore. So this angle, suppose this is it. So this angle and this angle will be adjacent. If I increase one more, then this angle and this angle will be adjacent. Okay, I'll write it, I'll make it big here. Suppose these are like, okay, A, B, C and D. So these two are adjacent, correct? Now I'm going to increase, I'm going to draw another ray here, right? E, suppose. So now this and this, so this and this become adjacent. There is no, because this becomes AB becomes a common arm, right? And BE and BD become the non-common arms. Whereas in case of ABC, in case of this angle here, BD is the common arm, right? And AB and AC are the non-common arms. So these two are adjacent that way. So you keep, if I even draw one more here, then again this becomes a BC becomes the common arm, and then 2 and 3 will become adjacent angles. Because one is not in
Ma'am, can you complete the last point of the definition?
Oh sure, yes. Common arm, common vertex, and non-common arms. Non-common arms are on different sides making sense now? Is it fine now, or should I repeat once more?
No, ma'am, got it.
Okay. So basically, this is how you figure adjacent angles if they give you, examples, or if they ask you to figure out. So they should have basically have a common vertex, a common arm, and they should be on different sides. So there are a few examples in your NCRT, I think. So let me see. I think I have it open. Yep. Oh, this blue line is there on my screen itself. Wow, I don't know from where this line has come. Okay. So they have given examples of oh no, they haven't. Okay, they had given linear pair examples. Okay. So this is adjacent angles, and then so in this case there is one more property which you can always say, like for adjacent angles, I'll write it here, that the sum of these two angles is always equal to the total angle, or how should I say? I'll just write. So the property here is, the important property here is angle I should have made it a little bit straight now. This becomes okay. I'll change the example. Wait, give me 1 minute. So basically what I'm trying to say is this is B. So angle DBC is nothing but the sum of angle DBA plus angle ABC. This property always comes in handy in case it is adjacent angle. Now the adjacent angle property can be further extended to something known as linear pair. How do you say that it's a linear pair? So okay, I'll just clear the screen.
Linear pair will be basically supplementary angles, right?
Correct. They will be supplementary, but I'm saying like it's nothing but an extended case of adjacent angles. Why do I say that is because of this. So as the previous example, right, this, it was something like this. So this is let's say A, B, C, D, and these are the two angles. Okay, now if these two non-common arms, right, DB and BC are the non-common arms, right? So I'm going to say that the two non-common arms lie on a line. Okay, the two non-common arms, if they lie on a line, this becomes a linear pair. Have you got the difference? Which is adjacent and which is linear? So basically, if you see anything with a straight line in it, it can be like this also. Right? This is, let me say, Z. My internet connection is XYZ and A. Why is my internet connection still unstable? Mystery. Okay. So this also, in this case also, xy is the common arm, zy and ya are the non-common arms, right? This and this are the non-common arms. Okay. My voice is lagging, is it?
No, ma'am.
It lags in the bit.
A bit? Oh, okay. Let me check my internet connection once. Okay. So I hopefully it will be fine now. So all I'm trying to say is this that a linear pair is basically an extended form of adjacent angles. How is that? That because if the non-common arms, like in this case I was showing here, yz and ya are the non-common arms, right? They form a line, correct? So when they form a line, it's called a linear pair. So it's just basically written like this, that I just write it here. If non-common arms, so it is for these small definitions that you need to know what is arms, what is vertex, what is array, right? Two non-common arms form a line. Just nothing but linear pair of angles. You get it why it is called linear pair, right? Linear will extend to something from the word line, right? So what is a line? A line is basically an infinite set of points, or 2 points extending in infinite direction. That would be a better way of saying it, right? So 2 points of two endpoints with infinite distance between them would be an apt way of saying what a line is, right? So this is the line, and line always is 180 degrees, right? And this is something of an extension. So this angle, or this adjacent angles on a line will always be equal to 180. That's the property we were coming to from all this, right? So what was I trying to say from this example itself? Let me just write it. I'm trying to say that dbc is equal to 180, or dbc is equal to dba plus abc, which is equal to 180. Cool. So this is one more important property. So three things we have come across, important concepts till now. One is complementary angles, then is supplementary angles, and then there is a property of linear pair of angles. What is the property? That the sum will always be 180. Wherever you see the word linear pair of angles, it automatically means that the sum is going to be 180. Sum of what, if you ask, will be the sum of the two angles, right? Because it says linear pair, correct? So the pair is equal to 180. Or I can also say that these angles are supplementary, isn't it? Just connecting all the concepts together. In this chapter is mostly revolving around that. So there is like 2-3 main points, and no, just a connection of all those important properties. Okay, should I move ahead?
Yeah, miss.
So this let me just check. I think you have Yep. So before we move on to that, I want to tell you two things. This is just for your understanding sake, not that you're ever going to be asked questions on this, or you're not going to be asked to tell the difference or define or anything. So there are two things you might have come across or you will come across in chapters like lines and angles, triangles, and maybe Euclid's geometry also. And so they are known as actually three things. I can add this also. Proofs is something you have been doing, right? You might have done it in lower classes also, correct? So there are three terms. So axiom, this is known as an axiom, this is a theorem, and this is a proof. Okay. So axioms are basically statements which are taken to be true. So they are statements which we are just going to believe that they are true. Theorems are how can I say, theorems are basically hypothetical statements. Hypothetical, right? Do you know the meaning of hypothetical?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes.
Like
Okay.
imagination.
Yes, correct.
Imaginary.
So these statements have been deduced from some sort of theory. Theorem actually comes from vaguely from the word theory. So based on some theory, they came up with a statement. Okay. So now but this is not true. Is not true. I'm going to write it here. Okay. Axioms are the statements which they came up. This also is based on some theory or some fact. Okay. But they are considered to be true. So you just take the statement as it is. Right. Theorems are hypothetical statements which are not true. So what do? You use proofs to show theorems are true. Are you getting it? Is it making
No, I
any
didn't
sense?
understand.
Didn't understand.
Yes, ma'am.
Okay. So see, there are certain statements, right? There are some theory. Like let's take the example of lines and angles itself, right? So the fact that I'm saying that, you know, adjacent angle, suppose I'll take this example, right? I just said that if adjacent angle has non-common arms on a line, right? It means it is a linear pair, correct? This is what we just stated. So I went one step ahead and I said that linear pair is supplementary, or some, I write it like this. Correct? I made this statement, isn't it? So this statement is nothing but an axiom because it is, you can see it, right? There is some kind of theory involved, and it is taken to be true, right? Now we take it that this and this angle, like angle 1 and angle 2, the sum of 1 and 2 is 180. We take it as the word because there is already a statement which says that linear pair is supplementary, correct? So that is nothing but an axiom. Okay, now if I am going to tell you something
But
like,
ma'am, if theorems have proofs, that means they are axioms, right? They can't be wrong if they have proofs.
yeah, so that is like an extended version. But so why they are called theorem is that you need to use mathematical operations and prove them. So since it involves the process of proving it, that's why they are called theorems.
But ma'am, if the theorems are proven, that's why we're using them, right? So how can it be hypothetical? Shouldn't they be axioms?
So that's the whole point, like the difference between theorem. I don't know how to explain it to you in very simple terms, but basically, when all this came into picture, axioms were that time itself, like when they came up with the concepts of lines and angles, let's say. So at the starting itself, those statements were taken to be true. That, like, at the starting itself, it was said that linear pair is supplementary. Okay. Now nobody disproved it, or right? All scientific provings or all scientific findings are disproved at some point, right? So many scientists were involved in proving something again and again. Take for this case, you can use the example that the earth is round, right? That debate is still going on, that few people still believe that the earth is flat, isn't it? So that's how should I explain it to you in simple terms, is basically axioms are statements which initially itself were taken to be true, and theorems were then that time they came up. So the scientists, when they were working on all these things, or in this case you can say mathematicians, they came up with certain statements which they felt might be true. So one person came up with it, then subsequent years somebody else came and tried to prove it. They use different methods. So it's not like,
So if theorems are proofs, then they become axioms.
you can say that in a way, yes. So but
So can Pythagoras theorem is be called as a theorem
yes, because if
or an axiom?
see, it's called a theorem because when you learn it, the first step you do is you learn to prove it, don't you? You learn the proof of it. So
Yeah, ma'am, but it is never wrong. Like it is, yeah.
so
But
but yeah.
like it's a theorem, but we assume that it's an axiom.
How should I say? So in your syllabus, they have only included theorems which are true. So that's why you are getting confused, isn't it? So there are n number of theorems existing. Most few of them which were proved true, few of them which were proved false. The false ones we are not studying at this level. They come, when you go into deep research. That time you find out that, oh, there are so many more theorems existing, but since they were proven false, they are not in use anymore. Okay. So at this stage, you are literally given both cases statements which are true. That's why the confusion arises. That's why I wanted to just tell you that there are two different things, something called axiom, something called theorem. So there are theorems other than ones you're going to learn, which exist and which prove, which have been proved to be false. Okay, is it making sense now?
Little bit.
Little bit. Okay, so for your understanding at this stage, you can just you know uh, think of it like this, that axioms basically don't need to be proved. So any case they tell you theorems need to be proved, right? So in this chapter itself, there are multiple theorems which are going to be proved also, which I'm going to show you how to prove them. We are going to do that. And there are certain statements which we are just going to be taking them as it is, like this linear pair is supplementary. We are not going to do further analysis on that. Of course, there is a way to show why it is so, but these statements, since they are taken to be true as they are, so we don't go into investigating why they are true. Or basically, I just wanted you to know, because your chapter notes have different headings. So I guess even in your NCERT textbook, you have different headings. One is known as axiom, one is known as theorem. So you might be wondering what is the difference, or why do they fall under different categories. So I just wanted to tell you that these are the different things. So maybe if I take it up, it will be maybe it will get clearer. Like when I show you with an example, maybe it will be better, isn't it? Okay, so we'll take up, so I'll show you the axioms. So you, in your chapter notes, this is the first axiom which we also covered right now, that if a ray stands on a line, then the sum of two adjacent angles so formed is 180, right? And one more important thing with axiom and theorems is that you can't write them in your own words. Like you either say, how should I say? You either there'll be a name for it, like Pythagoras theorem. So you can just say as you're using Pythagoras theorem and leave it, or you need to write the whole statement. Okay. So these two axioms, should I write them or is it fine from here? If I'm reading out from here, which do you prefer? Should I write these two axioms again or is it fine?
No, it's fine.
It's fine.
Fine, okay. So these first two axioms, you can make a note of it, like somewhere, that they are also known as linear pair theorem or linear pair axiom. Why is it linear pair? Is because you see the first one is says that if a ray stands on a line, they have shown you with an example. So BD is a ray which is standing on the line ABC or AC, right? So the sum of two adjacent angles so formed is 180. Why 180? Simple, because AC is a line, so line measures 180, correct? That's why. The simplest way to show. Okay, and the second one says the converse. So you say something which is reverse. The reverse statement is set. The term used for that is converse. So converse of that, this axiom is, if the sum of two adjacent angles is 180, then the non-common arms of the angle form a line. Is it making any sense, or do you want me to explain?
Ma'am, can I ask something?
Yeah, sure.
Like, it's not related to this statement you just said.
Okay.
So I'm reading something. Is this a theorem or an axiom? So it states that if two lines intersect each other, then vertically opposite angles are equal.
Oh, that I guess.
Axiom.
Yeah, it just states, right? It's already stating something. I guess
But
that's
like in the book, it is written as theorem. I don't know why.
okay.
Yes, no, 6.th.1.
Acha, you are reading this. If two lines intersect each other, then the vertically opposite angles are equal. Okay, so see, the axiom and theorem, they will sound the same. So it's not like, you will have a way to distinguish them. That is the whole point why I tried to, tell you the meaning, because like I said, it's not required at this stage, but I just wanted you to know that why certain statements are called axioms and why certain statements are called theorems. Even though they sound the same, they feel the same, isn't it? So just like for now, just keep this much in mind, that axioms don't need to be proved and theorems need to be proved. They might ask you theorems in your exam. They might ask you to prove them. Okay, they might uh, give you, say that, prove that, like you said. So they'll just give you proof that if two lines intersect each other, the vertically opposite angles are equal. So that is basically a theorem. And what do you do? So both axioms and theorems are used while solving questions. Okay, I'm really like, what I do is, after this class I'll try to see more examples on how should I make this concept of,
Miss,
yeah.
what is the difference between the first axiom and the second axiom?
Okay, so first axiom and second axioms are basically, if I use a mathematical term, they are reciprocals of each other. They are just the opposite. So the first one says that you have a line. Okay, this is the first one. That this is a line. Okay, and a ray on the line. So the angles produced will be, so the sum of the angles will be 180, is what the first axiom says. And what the second axiom says is that uh, this is something and this is a ray, but I have already given you that 1 and 2, you are given the condition that 1 and 2 is 180. Which means AB is a line. That's all. Making sense now?
So basically, they're based on the same principle.
Yes, they are just the opposite of each other. It's one statement which can be used in two ways. So they will give you questions where they will just say that so actually you will not get something so direct. They might just give you uh, some, how should I explain it? Okay, I'll take something difficult and explain it. They'll give you something like this, and yeah. So A, let's say B, C, D, E. Okay. So now from this, it is really hard to know, like, maybe because the lines look straight, doesn't mean that they are a straight line, isn't it? So in this case, they'll give you something like this, and then they will just say, suppose like this, they'll say 1 and 2 is equal to 180. They'll give you this. So from this, what do you know? They from this you can say that since 1 and 2 is 180, 1 plus 2 is 180, DC is a straight line, which means what? From this you can imply that this, and this also will be supplementary, isn't it? DC is a straight line, which means this angle, and this angle, the sum of these three will also be 180. Should I write like this? 4, 5, 6. Since they are given 1 and 2 is 180, so you found out DC is a straight line, and hence therefore you can say 4 plus 5 plus 6 is also 180. This is how you use the axioms. Is it clear now? Clear? Still thinking? You want me to repeat some response?
Oh, ma'am, got this part.
Got it? Okay. So so like I said, should I write it here? So the statement 1 is, or you can say 2 also, anything you can say. This is the term we use, converse of 2, or 2 is converse. You can write this down if you like somewhere, so that when you read, you are aware that 1 and 2, the axiom 1 and 2 are related. And how are they related? That they are the converse of each other. Okay, so we'll move on. This might take a bit time to sink in, so no problem. We have another.
Can you tell again what is a converse?
Okay, basically converse is the opposite of something. So there are two theorems here, right? So what is the first one? Say that if a ray is on a line. So okay, should I explain it in a simple way? I'm saying that
So you're saying that axiom 1 is a converse of axiom 2.
Yes. So basically, I'm saying that you know. Okay, I'll tell you in simple terms. If AB is a line, angle 1 plus angle 2 is 180. This is what the first one says. Okay, and the second one says if 1 plus 2 is 180, AB is a line. Is it getting clear now?
Yeah, ma'am.
Okay, should I like take some simple real world example and explain it to you? Like suppose I'm going to say, okay, this is a bit tough. Okay, yeah, something like this. Something like this. So you would have heard of like, let me take this. Let me take one of your example, like Neki. Okay, so I'm going to say Neki has lemons, which means she's going to make lemonade. She will make
That is not juice.
lemonade. Okay.
What?
Huh? Sorry, I didn't get you. Okay. So this is a statement, right? So what is the converse of this? Converse of this will be Neki has made lemonade.
You write the second part first and then link it to the first part.
That is you know, that will be a very simple way of saying it, but in general if I want to explain something to you,
So the result will be same.
yeah, basically it's the same thing. So I'm using one part to prove the second thing or the second part to prove the first part. That's all. So Neki has made lemonade, which automatically means she has lemons, isn't it? Right. So this is exactly the thing happening here. So they are saying AB is a line, which means 1 plus 2 is 180. Okay. So if 1 plus 2 is 180, which means that AB will be a line. Definitely will be a line. Making sense now? And when you write such things, they are known as converse. So these two are converse of each other. You know that shoe brand which is there, Converse. You can use that to remember. Did it get little bit clear now?
So, ma'am, how will the question be based on this?
Question is going to be like I showed you in the previous slide. It's just going to be a mix of lines. So they'll give you, you know, something like this. Okay, it will be, so from this figure you cannot identify, right, which is a straight line. Okay, I'm just, if I draw this random figure, you really cannot say that is EF a straight line or is AB a straight line or what is it exactly. But if I give you something like angle, what is this, oh, I have not labeled this. Oh, okay. So if I am giving you AOF plus BDF is 180, which automatically means what? AB is a line. Isn't it?
Yes, ma'am.
Yeah, so they'll give you some complex figure like this and ask you to find, suppose they tell you find the value of this angle. So you need to use all of these axioms which are there and find that out. So this is just one. I'm going to give you 2-3 more which will also be used. So you have to memorize those properties, those theorems, axioms. So there are different things, properties, theorems, axioms. So mix of them will come in handy to solve this question or some questions like that. this chapter, the only direct questions you are going to get is for complementary and supplementary. For everything else, it's going to be just some random figure, and they'll ask you to find some value of some angle. Okay, so if this is clear, shall we move on ahead? We need to cover parallel lines. Okay, don't worry,
Yes, ma'am. Sure.
might sound little difficult right now, but when we do the questions, when you see the application of it, you will, it will slowly start falling in place. Okay. Yeah, so we did the two axioms. So yeah, okay, theorem may, okay, yeah, so we need to do the theorem now. Okay, so there is one concept which is known as vertically opposite angles. So suppose there are two lines. Let's say this is AB and this is CD, correct? So they intersect each other, right, at this point O. Okay, so basically the definition of vertical angles is vertically opposite angles is they are formed when two lines intersect each other. So what are the vertical angles going to be in this case?
AOD and COB.
Yes.
AODCOB.
So yes, you all are right. So the ones marked in blue will be vertically opposite, and the ones marked in black, I'll label it. So angle 1, angle 2 are vertically opposite, and I'll write it A and B. Angle A, angle B are also vertically opposite. Clear? Okay. So there is a theorem which we are going to come across, which we are going to do now. It is based on, let me just write theorem 1. It is based on vertically opposite angles. So all you need to do is you need to show that vertically opposite angles are equal. Okay, it's very simple. So yeah, so if two lines intersect each other, then the vertically opposite angles are equal. Okay, should I write it here? If two angles, oh sorry, if two lines you can make a note of this, okay, whatever I'm writing. Intersect each other vertically opposite angles are equal. Okay, so we are going to prove this. Okay, for that I'm just going to make a diagram here. Diagram should be made in pencil. Okay, yeah, I will be sharing the recording later, definitely. Yeah, but it is, since I'm doing a proof, I thought if you write it as I'm explaining, it will be a better way of memorizing, be easier to memorize. That's all. So what do I have to prove? That these two angles, and okay, I'll use green color. These two angles are equal. So how do you do that? Just give me a second. Yeah. So we did one. We have covered one axiom, right? So we are going to use that axiom to prove this, isn't it? So what does it say? So let me write here. Okay. So already in the theorem it says lines, isn't it? So basically AB and CD are lines. What does that imply? Can somebody tell me?
Ma'am, that their measure is 180 degree.
Awesome. Yes.
I mean, that some of their angles is 180 degree.
Yes.
Like you just, yeah.
Correct. That's right. So AB and CD are lines. So I can say that, let me consider AB first. Okay. If in case of AB, I can say that angle AOC plus angle COB is 180. Correct. What do? You write here. Why is it 180? So you write here linear pair axiom. The reason always you write in the brackets. Okay. And also, since I say CD is a straight line, isn't it? CD is also a line, which means angle COB plus angle BOD is 180, isn't it? So now same thing. So you write the same reason here. I've just put inverted commas. You can write the reason. Okay. So let's say this is equation 1. This is equation 2. So combining we can say, what can we say? COB and COB is common, right? So OC. Oh wait, I'm doing some other proof only. Wait. So AOC okay, I'll write it in simpler words. Just a second. Don't combine it. So from 1, what can I say? I can say AOC is nothing but 180 minus COB, isn't it? And from 2, I can say that BOD is nothing but 180 minus COB, isn't it? So from here, what can I say? AOC is equal to BOD. What is AOC? This one. And what is BOD? This one. So we've proved. Correct? Did you get it? It's pretty simple.
Yes, ma'am.
Cool. Yeah, so similarly, you can prove for the other two also. What is the other two? COB and AOD. Correct? Similarly, prove for COP and AOD. Okay. Simple theorem. Cool. So I'll quickly go on ahead. What should I cover now? Okay, so now I have to cover. Okay, we move on to parallel lines. So you would have come across parallel lines, right? Before, have you done that?
Yes, ma'am.
Yes.
Do we explain what it is? Or what?
Huh? Sorry. Okay, so suppose this is a line M, this is a line N, and they are parallel. So I'm going to draw a line which intersects these two lines. So this line L is known as a
Transversal.
awesome. L is a transversal. Or what is the transversal? Shall I write it down? Transversal is basically a line which oh, which intersects two or more lines at distinct points. So it says it intersects two or more lines. So the lines don't need to be parallel, but generally we use the word transversal in case of parallel lines. Actually, we use it more often to denote like for parallel lines, but it can also be something like this. Okay, I'm just going to make a rough figure here. It can also be something like this. So these lines are not parallel, right? Say P and Q, and there is this line here, say A. So A is a transversal. Cool. Okay. So now we are going to. Okay, I'm just going to. So there are few concepts I want to know from you. I think you would have done this before, isn't it? So what are the exterior angles here?
2,
One
3 and 8.
angle 1, 2, 8, 7.
2, 1. Yeah. 2,
And
1 and
angle
8,
1, 2,
7.
8, 7.
Yes.
287.
So there are 4 exterior angles. And interior?
4.
4, 3 and 5, 6.
Awesome.
4 angle 3 angle 5 angle 6.
Okay, so this was easy, right? Anybody who doesn't know this, like, who needs a recap or any such thing? There is one more interesting term, which is known as corresponding angles. Anybody?
2 and
It is
6.
2 and 6, 4, 8, and 5,
6, 1, 5, 2, 4,
and 3, 7. The
Okay.
complement.
1, 5.
Yes, you all are right.
Ma'am,
So, huh?
what do you call 3 and 8? There's a term, there's one more term that includes 3 and 8, or 3 and 5.
Interior
Internet
alternate angle.
alternate.
Yeah, so that will be 3 and 5. 3 and 8, I'm not sure anything includes that. Or they're just alternate angles, actually. 3 and 8 will be alternate. 3 and 5 will be alternate interior. We'll come to that. Okay, so corresponding angles are basically you leave one and take. The simplest way of putting it. So 1, you skip 4 and 5. So 1 and 5, 2 and 6, 3 and 7, 4 and 8. And write them down. 1 and 5, 2 and 6, 3 and 7, and 4 and 8. Okay, so this was, I'll write those things here. So we're done with, so this is what you all were talking about. Alternate interior angles. So that will be 3 and 5.
4, 6.
4 and 6, yes. Okay, and there is one more which is alternate exterior angles. Will be simple, outside ones. So it will be 1 and 7, angles which are exterior and which are alternate. 1 and 7 and 2 and 8. 2 and 8. Yes, and the last one, which is very important, which is crucial for quite a few theorems and most of the questions, is,
What was 4, ma'am?
oh, I skipped 4. Okay, there is no 4, sorry. And then this is 4. Okay, I'll change it here. Thank you. This is 4. This is 5. Okay, so yeah, the last one is known as, so there are multiple terms for this. The simplest way to denote it is interior angles on the same side of the transversal, or it's also known as allied angles. Write this one down, or consecutive interior angles, or the most famous term, I'm going to write it in another color because this is the term mostly used, co-interior angles. And what are these angles? This is basically angles on the same side of the transversal as it says. So it will be 3 and 6.
Miss, can 3 and 6 be called adjacent angles?
Sorry, 3 and
6 can they be called adjacent angles?
no, see, the definition of adjacent is they have a common arm, right? So 3 and 6 don't have a common arm. 2 and 3
Yeah,
will
ma'am,
be
this
adjacent.
one.
2 and 3 have a common arm. See, 2 and 3 have this common arm, which is this line here, isn't it? 2, 3, 1, 4 are adjacent, 5, 8, and 6, 7 are adjacent. 5, 6 is adjacent, 3, 4 is adjacent, 1, 2 is adjacent. Okay, so these are the most important points you need to know in case of parallel lines. Clear? 90% of the times you're going to use properties involving co-interior angles. What is co-interior? 3 and 6 and 4 and 5. or angles which are on the same side of the transversal. Okay, so if you look closely, what can you say from this? There is one property which we just learned which can be applied here.
Supplementary?
Supplementary, yes. And one more. What we discussed just before this.
The axioms?
No. I'm saying we just discussed something before I started parallel lines, right? That.
Vertically
Vertically
opposite.
opposite angle.
Yes. So it can be applied here, isn't it? So from that, we can say that this angle and this angle will be the same. This angle and this angle will be the same, isn't it? So this vertically opposite angle theorem is going to be used a lot because now the next proofs all involve parallel lines and all these angles. So that is the main one which is going to be used. Okay.
Ma'am, can we do a sum or something? So that
Some actually I was thinking we'll take up later once I'm done with all the theorems, because without that I can't really do a sum. Then I can only do complementary and supplementary sums. So what we'll do is we'll finish the theorems this class, and then next class we'll do sums. Okay.
okay.
So, ma'am, the magnitude or the angles, no, interior alternate angles and corresponding angles, or these are equal, right?
Interior alternate angles. Yeah. So we are going to be proving that. Yes, you're right. So our next job or next step is to be proving all those things itself. Yeah, there you go. So the two main axioms. So again, these two are converse of each other. And what does it say is that if a transversal, okay, so this statement is written twice, so just ignore one of them, right? This one and this one. Okay, should I highlight which I'm saying? This statement is the same as this statement. Okay, so just ignore one of them. So what does it say? If a transversal intersects two parallel lines, then each pair of corresponding angles is equal. So should I show it to you? Okay, so this is right. If M and N are parallel, M is parallel to N. This is how you denote parallel lines. This is L. And now what are they saying? They are saying corresponding angles are equal, which means 1, 5 is equal. Also, two and 6 is equal, isn't it? And there are more. So there will be more. This will be this 4 and 8 is equal, and I need another color. 3 and 7. You got it right. So these are all the possible corresponding angles which are there, out of which 1 and 5 will be equal, 4 and 8 will be equal, 2 and 6 will be equal, and 3 and 7 will be equal. That's what the axiom says. And the reverse of it, or the converse of it, is if the corresponding angles are equal, then two lines are said to be parallel. Clear? So there are a total of only 4 important axioms in this chapter. Two are called the linear pair axiom, isn't it? And there is no name for these two, so they are just statements. Which is, you got it right. So in this case also they're opposite. That, okay, should I just write it and show that what is the first statement saying? That if M is parallel to N, then 1 is equal to 5. Okay, angle 1 is equal to angle 5. Or angle 2 is equal to angle 6. Or you can add all of them here. And what does the second one say? If angle 1 is equal to angle 5 or angle 2 is equal to angle 6 or any of them, then M is parallel to N. Simple? Is it clear?
So if they give one part in the question, like in the question they state that M and N are parallel, then we can write that according to the theorem, angle 1 and 5 are equal.
Yes. Yes, that is exactly what we need to do while solving sums. So they are just going to give you, like I said, they'll just give you a figure. So you have to identify, they might just give you something. Okay, since you're done with parallel lines, I can give you something now. So they are going to give you something like this. There's one question which looks like this in the book. Okay, and they'll ask you to find out this angle, X. Right. So when you know all these theorems together, it becomes easy to identify that these two will be parallel lines. Some they will mention it somewhere. Okay, they might give you a small hint, or they might say some angles are equal. So then using this property that this and this are parallel lines, you find out which are the corresponding angles, you find out which are alternate interior angles, and then you find out this X. Or basically you just draw another parallel line here. That's what I'm saying. So unless I show you all the theorems, I won't be able to solve questions actually, because they involve the use of most of the theorems together. Okay, so we'll take up the next theorem then. Theorem 2. What does it say? Okay, so we did the vertically opposite angle 1. Okay. If a transversal intersects two parallel lines, then each pair of alternate interior angles is equal. Okay. So till now, what have we got? We have got that we've got the supplementary clause. We have got the vertically opposite angles are equal statement. Then we've also got the fact that if two lines are parallel, then corresponding angles are equal, isn't it? Now we are going to prove that alternate interior angles are equal. Okay, so I'll just write it here. If a transversal intersects two parallel lines, yeah. For transversal intersects two, I'm just writing the symbol for parallel lines, okay? Two parallel lines, alternate, each pair, okay, each pair of alternate interior angles is equal. So I'll draw a diagram and show. Right? So M and N are parallel lines. L is the transversal, isn't it? So what is the theorem says? Each pair of alternate interior angles. So this and this is alternate interior, correct?
This. पता है पर ये बोल रहा हूँ.
Somebody saying something, sorry. Okay, so 1 and 2 are equal, and let's say 3 and 4. Okay, so we need to prove this. Isn't it right? Yeah. So we use the corresponding angles axiom and the vertically opposite angles axiom. So how do we use that? Let me just see. BQR is equal to Q. Oh, somebody has a question. Yeah, you can write this. This is there in the chapter notes. I'm just explaining it to you. So your wish, you can write it. PQA is equal to. So yeah, they have proved that corresponding angles are equal, and yeah. Okay, got it. So basically what have they done is, okay. Need to prove that, isn't it? Angle 1 is equal to angle 2 and angle 3 is equal to angle 4. So from, I'm just going to name these properly, since, let's say this is AB, this is CD, and this is a line PQ. Okay. So, proof में we can write that PA. Oh, I'll have to label this also. Okay, let this be O and this be R. So POA, angle POA is equal to angle ORC. I'm talking of this angle. This angle POA is equal to this one 4 ORC. Why? Can anybody tell me why?
Ma'am, because line AB and line CD are parallel, so hence the corresponding angles are equal to each other.
Awesome. Yes. So we just write corresponding angles, right? And what is the other thing we know? We know vertically opposite angles are equal. So we know that POA will be equal to BOR. You got it right. Huh? Sorry, what?
Angle ORC is equal to angle BRC.
ORC will be equal to angle B.
RQ.
How BRQ means? BO something will come. DRQ. Yes, this also is true. So POA, which is this angle. So I'm just, yeah, this angle is equal to this angle, or yes, this as well. You can use this angle is equal to this angle. In this case, I took POA and BOR because I want to show that 3 and 4 are equal. I'm trying to show 3 and 4 are equal, right? So POA will get cancelled because it's the same. So if this is statement 1 and this is statement 2, so from 1 and 2 we get that. What do we get? ORC is equal to BOR, which is ORC is this one right here is equal to BOR is this one. So I have proved that angle 3 is equal to angle 4. So you can do the similar steps and prove angle 1 is equal to angle 2. Similarly prove. Okay, got it. Easy, right? So see, we learned statements for vertically opposite. We learned statements for corresponding angles, isn't it? And now we are using it, applying it. What time will class end? Class will end after 5, somewhere like 5 or something. Okay.
Ma'am, if we are asked to prove like 3 is equals to 4 and 1 is equals to 2, after proving one set, can't we just write that as both are interior alternate angles, that's why angle 1 will also be equal to angle 2?
Yeah, you can. And so this will totally depend on the marks of the question actually. So if it is for 2 marks, you can just prove one part and leave it. If it's for 3 or 4 marks, you might have to prove both the sets. Okay. I'm not really sure if theorems are asked in your exams. I'm not sure of that. But since they are there in the NCRT as well as the workbook, I am explaining them to you so that in by chance they are asked, these are very simple theorems. You can prove them easily. Okay. Okay. So next year we'll go on to the next theorem, which is okay. If a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. So this is the converse of what we just did, isn't it? Does the statement sound little, is it a bit complicated, or are you all understanding? What happened? No response.
Understanding.
Okay.
Ma'am, we're understanding.
Okay. So this statement is the converse of just what we just proved, that so we just proved, right, that if if a transversal intersects two parallel lines, then the alternate and interior angles are equal. So the opposite of that is if a transversal intersects two lines such that the interior angles are equal, then the two lines are parallel. Okay. So we'll go to the next one. The next one says if a transversal intersects two parallel lines, then each pair of the co-interior angles is supplementary. Okay, this is interesting. So what does it say? So there is no proof for this. If you want, I'll just explain it to you why they are supplementary. If a transversal intersects, okay. Intersects two parallel lines, each pair of the so what are co-interior angles? Sorry? So what are co-interior angles?
Some co-interior angles are the angles that are lying on the
same transversal, same side of the transversal.
Yes, correct.
Interior angles that lie same side of the transversal.
Yes, correct. So this, let's say this is AB, this is CD, this is EF, and this is OR. So what are we trying to say? That these two angles are co-interior angles, and we want to show that these two are supplementary. Anybody has an idea how we'll show that they are supplementary?
Yes, ma'am. Like we know interior angles, like adjacent angles sum up to 180 degree. So,
Correct.
ma'am, angle COR is the interior angle of ORF. So it is the same as that.
Cool. Awesome. So I didn't get your name. I can't recognize your with
Puneet.
voices. Puneet. Okay. So Puneet has answered, has given us the answer, and wonderful answer. So I'm just going to write it here quickly. Okay. To prove, so you can write this down if you want. This proof is not given in your chapter notes. I don't know if it's there in the textbook. So if you want, you can write this down. To prove COR is COR plus, what is that? ERO or ORE, sorry. Okay. COR plus ORE is equal to 180.
And there's another way we can say that these will be 180.
Okay, tell me.
Ma'am, angle AOC plus angle COR is equal to 180 degree too. So angle
AOC plus,
COA
yes.
is equal to ORE because of corresponding angle
Awesome.
as CAOC. So this will come as 180.
Correct. So now you have two ways to prove this. Awesome. This shows that you all are understanding the chapter. I'm glad. So yeah. So proof में two ways of doing it. So I'll write here. First method. First method is what? Angle. So angle COR plus angle DOR is 180, isn't it? Linear pair. So we write that linear pair axiom. Oh, my M went off. Okay. And what do we know? That angle TOR is equal to angle ORE because they are alternate interior. Therefore, angle COR plus angle ORE is equal to 180, isn't it? Or oh, it became poof. Proof. Second method. Okay, he said corresponding angles, right? So angle AOC plus angle COR is equal to 180, linear pair, correct? And angle AOC is equal to angle ORE because they are corresponding. Therefore, angle AOC, oh, so it won't be B angle ORE plus angle COR is equal to 180. Cool. Nice. I'm glad you all answered. Yes?
More ways. Similar, but then we can take DRE also.
DRE. Huh.
DRE.
Correct. Yeah. So these two methods can be applied on the other side as well, like on the side of, using angles BRE or BRF. You can also use the, no, that won't be useful. Okay, yeah. So yeah, you can use the same things for BRF or BRE and prove that, show that this angle ORE is corresponding to angle AOC. Nice, great. So we'll move on to the next one, which is lines which are parallel to the same line are also parallel to each other. Okay, yeah, in this case, I think they use corresponding angles. Yep. So this is simple. I'll just quickly show you. Okay, then what we can do is we'll do this theorem. Then we'll be left with, okay, I'll cover those also. It will take 10 more minutes. So then after 10 minutes, class will be over. So theorem 4, yeah. Lines to the same line are also parallel to each other. So basically they are saying, suppose there's a situation like this, that yes, class will end. Okay, what I'll do is I'll just do this theorem. Maybe we'll do the triangles theorem in the next class. So let me just finish this. Okay. Suppose there are three lines, three parallel lines. Okay, but they say that so they have given that M is parallel to L and so wait, M is parallel to L and
N is parallel to L.
okay, so this and this and this and this and N is parallel to L. Okay, so you need to prove M is parallel to N. So we already did an axiom, right, for this, that if corresponding angles are equal, which means lines are parallel. Do you remember that one? So this is the one I'm talking.
We can also say that the line P is a transversal which is intersecting the line M and N. So can't we just use that statement as a proof to show that M and N are parallel?
No, see, so transversal actually can intersect any line. So it's not just for parallel lines. That's why in each theorem we state specifically that a transversal intersecting two parallel lines or two lines. We are mentioning that. So we can't use that. What we can use is this axiom, which is if a transversal intersects, if a transversal intersects two lines such that a pair of corresponding angles is equal, then the two lines are parallel. So we just need to show that the corresponding angles are equal. So how do we show? So we can consider angle to be this 1, this as 2, and this as 3, isn't it? So since sorry, I couldn't hear you. Was anybody saying something? Okay, so we already know. So since M is parallel to L, what can we say? We can say that 1 and 3 are corresponding, isn't it? And since N is parallel to L, we can say that 2 and 3 are corresponding.
Ma'am,
Yes.
even in the case that a transversal is intersecting two lines which are not parallel, even then corresponding angles will be equal.
So see, the concept of corresponding angles comes when lines are parallel. So only if they are parallel, there is a concept of the fact that corresponding angles are equal.
Okay.
So without knowing that, it will just be two lines and just be angles. So we won't be able to show anything. Okay, so the key point here is that the transversal is passing through two parallel lines, and that the corresponding angles of those parallel lines are equal. That's why corresponding angles can be used to prove that it's a parallel line, not just the transversal. Okay, so from here we get that 1 is equal to 3 and 2 is equal to 3. Therefore, 1 is equal to 2, isn't it? So M is parallel to, you know, right? So this symbol here, what I'm drawing, this is nothing but implies. This implies that M is parallel to N. Cool. Okay, so we are left with two more theorems of this chapter, which is why the sum of angles of a triangle is 180, and the property that exterior angle of a triangle is equal to the sum of alternate interior angles. So what I'll do is we'll do that when we do the practice session. Okay, so that will be fresh in your mind when we do the sums also. Okay, anybody has any doubts?
No, ma'am.
Ma'am, can you repeat theorem 1?
Theorem 1, which is that?
Yeah, ma'am, I got disconnected.
This one, if two lines intersect each other, then vertically opposite angles are equal.
Yeah, ma'am.
So see, in that, if two lines intersect each other, so I'll quickly draw and show you. Okay, so they are saying that two lines intersect each other. Okay, let those lines be AB and CD. They intersect at a point O. You need to show that this angle is equal to this angle. How will you show this? That this angle is equal to this angle. So what do you do basically? You show that angle AOC plus angle AOD is equal to 180. Isn't it? They become a linear pair. Right? So, and also you can consider this case like angle AOD plus angle DOB is equal to 180. So from here I can say that DOB is equal to nothing but 180 minus AOD, and from here I can say that AOC is equal to 180 minus AOD, right? So let me say this is 1 and this is 2. From 1 and 2 AOC
मुझे खा भी नहीं था.
DOB. Done. So we prove these two are equal. We
I'm
use
not even
the
eating right now.
linear pair axiom.
क्या बोल रहे हो? क्या बोल रहे हो?
Linear
नहीं, मैं खा भी नहीं रहा बोल रहा हूँ.
axiom.
तो मुझे क्या मालूम कहाँ है? मैंने नहीं खाया है.
Whoever asked this doubt, is it clear?
Yeah, ma'am.
Awesome. Any other doubt? Okay, then you
No,
can.
ma'am.
Oh, somebody said miss. Yes.
Thank you, ma'am.
Miss, I just asked that right now you just explained the theorem 1, right?
Huh.
Because I just got disconnected.
Yes, I explained theorem 1.
Okay.
Okay, then you can leave. We see you
Okay,
next
thank you.
class. Bye bye.
Bye, ma'am.
Bye,
Bye.
ma'am.